Everybody, going to be broadcasting the solutions to lab 1.3, and this lab was about double replacement reactions. Two smiley faces. Yay! How y'all doing? So we're going to go through. For the first one, you wanted to make a copper-based precipitate. You obviously had to use tube 6, which was the copper chloride solution. You could have used either the sodium hydroxide solution, which is tube 1, or you could have used the sodium carbonate solution. This was tube 6, this was tube 1, or tube 2. You're going to make the copper hydroxide or the copper carbonate. Both will work. Record your observations. You should have seen some sort of goopy, insoluble precipitate being formed. You're going to draw a picture of it below, and you're going to label the components. So this component would have been the copper hydroxide or the copper carbonate, depending on how you did it, and this component in here would have been the soluble sodium chloride that was left over, or the actually in both cases it would have been solid sodium chloride left over, so that's what that would have been. Write the balance reaction. Be sure to cancel the spectators. Cu2 plus Cl minus plus Na plus OH minus. Swap, stick, there it is right there. So you have the ions in solution, and you're left with your insoluble copper hydroxide precipitate. Cancel our spectator ions, and your balance reaction should be like so. If you did this with the other one, your balance reaction would be like this. Notice that this one you had to balance because of those two OHs. Cobalt precipitate. Now, what I'm going to do here is, this is going to be the same as above, but use COCl2 instead of Cu. So every place where you see a Cu, if you substitute it with a CO, if I made this a CO, made this a CO, this a CO, you would have you will have that reaction done. So I'll let you go ahead and do that. I don't think that would be too bad, but your final answer after you do everything should have CO2 plus 2OH minus goes to COOH2, or CO2 plus 2OH, or CO3 2 minus goes to CO3. So I want you to please fill everything in, draw your picture, but your label is just going to involve the cobalt instead of the chloride, or instead of the copper. Okay, an insoluble silver-based precipitate. Well, obviously we're going to have to use the silver nitrate, which I believe was in tube 4. So the silver nitrate is key, because that's the only one that really has silver in it. Remember, nitrates are always soluble, and you can react it with lots of different things. Why don't we just choose, in this case, the one would be CO3 2 minus. It would also work with sodium chloride. It would also work with sodium hydroxide. So you really have three options. I'm going to show you this one. It tends to be the more difficult one to look at. As you did it, again, you should see a cloudy, insoluble precipitate. In this case, it's cloudy. Write and balance this reaction. Well, I'm going to write and balance it, and then we're going to draw the test tube so you can see what it looks like. Silver nitrate plus sodium carbonate. Swap, stick, there's your stick. So NO3 minus Na plus. You know, Whenever you write a nitrate, you're always going to see the ion for the nitrate because it's always soluble. Ag2CO3, cancel, 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 cancel. In our tube, if you were to draw that out, this would be what's down in there, and this leftover solution would be what's there, because you do see the ions. Finally, we have Ag plus, 2Ag plus, CO3 2 minus goes to Ag2CO3. Carbon dioxide gas. All right, according to our stick chart, in order to have carbon dioxide gas, you got to have H plus reacting with CO3 2 minus. Okay, you should see bubbles when they mix. Place a few drops of bromothymol blue. Yes. Solution turned yellow. I'm confirming that bubbles were indeed CO2. Write and balance this reaction. H plus Cl minus plus Na plus CO3 2 minus. Swap, swap. This swap here is not from the solubility chart, it's from the stick chart, and we know that anytime you have hydrogen and carbonate, you're going to make water, you're going to make CO2. Cancel our spectators. Balance reaction is 2H plus CO3 2 minus goes to H2O plus CO2. Two solutions, though, to make ammonia gas. We know that if we have ammonium, and in this case we're going to take ammonium chloride, and that reacts with a hydroxide, you're going to make it. It should have smelled bad. The ammonium really made it smell bad. Did your observations confirm? Yes. NH3 smells bad. Oh, that's sad. I don't like smelling bad things. Choose two solutions that would produce water. Now notice this. Oh, I didn't balance the reaction. Right, balance this reaction. NH4 plus Cl minus plus Na plus OH minus. Okay, these are going to hook up, and you're going to NH3 plus H2O plus Cl minus Na plus cancel, 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 cancel. NH4 plus OH minus goes to NH3 plus H2O. Notice this produced water and this produced water, but that's secondary. It was really the carbon dioxide that was the driving force. It was really the ammonia that was the driving force there. In this case, they want water as the driving force. So that's when you have something with H plus, and that would be reacting with something with OH minus. And this one really just looked, why don't we say watery? That was a really hard one to observe. Yes, looked watery. Kind of a stupid question, but whatever. Let's write and balance it. H plus Cl minus plus Na plus OH minus. Swap, swap. Where's my stick? There's my stick. Cl minus Na plus H2O. Boom, 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 boom. H plus OH minus goes to H2O. There's the balance reaction. Okay, so guys, what's up next is going to be the AP problem. So I'm going to stop here and post the AP problem as a second part of this video. Thanks a lot. Bye.